Alrighty, continuing on with the review. Lesson 9.3 was on constant rate of change and slope. And that and is maybe you're thinking these are two different things, but rate of change and slope are pretty much the exact same concept. A line has a constant rate of change. The slope of the line is a measure of that constant rate of change. As before, there's different representations. We could have a table of values and look at how things are changing. But I could take these and consider this as an X and a Y and put them on a graph. So I could do this with a graph. I can do this with a table. So let's take a look at the example 3 here that is worked out. It says find the constant rate of change. So that is wanting me to figure out how is one thing changing compared to how the other thing is changing. And as I mentioned in class, we always measure it by how does the second thing change compared to how the first thing is changing. So you always take the second change compared to the first change. So some of you are flipping those two things around. It's always, think of it as if I had the time, then I would get the water level at that particular time. So the water level depends on the time. So I want to know, how does it change compared to a certain time change? This is the one that I would be controlling. If you look at example 10, you control the time that you work. You don't necessarily control the money that you're earning. You control the time. So money depends on time, and we want to know, how does this dependent variable change compared to how the time is changing. So pretty easy to show some work on these is you can just show the changes right on the table, and that is easy work to show. So if I look at the time from here to here, what did it do? Well, it went up 4, and so I'm going to put a little +4 there, and then I look at this one, and nicely enough, it's a +4 as well. Now those don't have to be the same. In this example, they are the same, and that's kind of nice, but they don't have to be at all. The water level, let's take a look at what happened here. So it went from 5 to 4, so that didn't go up 4. In fact, it went down 1. And then this, from 4 to 3, it went down 1. And so these are how the times are changing. This is how the water level is changing. To get the rate of change, you take the second change divided by the first one. Now, since both of these are the same two numbers, I don't need to do the calculation twice. And you can see it right here. They just took 5 minus 4 to get the 1. I just say, hey, the change is -1. The first change was adding 4. And if you take -1 divided by 4, you get -1/4. But since this actually has meaning in this table, feet and minutes, this is a measure of how quickly things are changing. The water level is changing. It's going down 1/4 of a foot, 3 inches. It's going down 1/4 of a foot every minute, per minute. So 1/4, so it goes down 1/4 of a foot, down 1/4 of a foot. Each minute it's going down 1/4 of a foot. So if there are labels and meaning to these numbers, then you can put that sort of a label on your result there. So let's take a look at it, number 10 here. Number 10, we have the exact same sort of information. So I'm going to do the same thing I did over here. I'm going to do up 4. Okay, that's the exact same change as before. That's kind of nice. And then I'm going to go up 4 here. So +4, 4 plus 8, or 4 plus 4 will give you the 8. And then as before, I'm going to do this change. This goes up 31. That was pretty easy to do, 0 plus 31. And then this goes up another 31, so another plus 31. And so there's my work in the table, but I'm going to come down here and my calculations for the rate of change, I'm going to call it the ROC. The rate of change is the second change here divided by the first change. So I'm going to take 31 divided by 4. Now those are both positive, so I didn't bother putting the little plus signs. 31 divided by 4, If you do that division, you can put it as a mixed number, I suppose. 4 goes into 31 7 times. 7 times 4 is 28, so there's 3 left over. So 7 3/4 if you wanted it as a mixed number. Since this is money earned, I'm going to actually put it as a decimal. 3/4 is 0.75. So I'm going to write it like that because to me it makes sense to do a decimal number for a dollar and cents thing. So this is $7.75, but I divided it by 4-hour change. So this is per hour. So in this particular problem, it means that whoever is doing this work, they are earning $7.75 per hour the whole time. So this is constant rate of change. So they don't get different pay depending on how much they work or anything like that. It is a constant rate of pay the whole time. Let's take a look at number 11. Now let's look at 12. Since you can check your own answer on there on the 11, let's do number 12. We are asked to find the slope. So on number 12, we are going to use what is called the slope formula. For some mysterious reason, slope is always referred to as m, and so I'm going to continue with that. Basically, how we're going to calculate it is we are going to take the difference in the y values divided by the difference in the x values. Difference in the x's. So there's a fancy little formula. Remember the y2 minus y1 and x2 minus x1. I just remembered it back in the day as difference of y's divided by difference in x's. And so what I'm going to do is I'm going to take this x and y and this x and y, and I'm going to subtract the y values. And I have two choices. I can subtract 7 minus a negative 1, or I can take -1 minus 7. Either way is great. I just need to decide which way I want to do it. I'm going to subtract this way. So I'm going to have 7 minus a -1. And I put that -1 in parentheses since it was minus a minus. That gets a little confusing. So minus a -1, put it in parentheses. On the difference in the x's, here's the only thing I have to make sure I do. I need to subtract the x's in that same order. So I can't go 5 minus a -3. I have to take the x that was in the same place as the 7. So I have to subtract -3 minus 5. They both have to be subtracted the same way. So then we have -3 minus 5. And now I just need to do both of these calculations and see what I get. So 7 minus a -1, if you call minus a negative, is the same as plus a positive. Taking away a -1 is actually a positive change. So 7 plus 1, the numerator is 8. In the denominator, we have -3 minus 5. If you're 3 in the hole and you lose 5 more, you are now 8 in the hole. So it's 8 divided by -8. If this was just reduced as a fraction, that's great, but this actually reduces to an integer. It'll be negative because one of them is -1 is positive, and then 8 divided by 8 is 1. So this is going to be -1. So the slope of the line between those two is -1. And what that means is from one of those points to the other, I could get there by going down 1, right 1, down 1, right 1, over and over again. Because I could think of that slope as -1 over 1, down 1, right 1, down 1, right 1. So I should be able to move from one point to another on that line, and doing 8 of these changes will get me from one of these points to the other. And so now let's take a look at might as well do 13 here, and then I'll be done with this little section. I'll let you do number 11 on your own. Hope that's not too much work. A lizard is crawling up a hill that rises 5 feet for every horizontal change of 30 feet. So what this is meaning is the horizontal is like the x, and the vertical is like the y. So a horizontal change in x means the x's are going up by 30. And then the y's are going up by that 5 feet. So they are going up 5 feet. So every time there's a 30 increase in the horizontal, there's a 5 increase in the vertical, or the up and down. So if we think about it, what did we do up here on the example 3 and number 10? We took the second row divided by the first. We took the second row divided by the first. So if I think about it, this vertical change is the top of my rate of change. So it asked me to find the slope. I'm going to find the slope by taking the vertical change, the difference in the y values, which is the 5, and dividing it by the difference in the x value, which is the 30. Very probably tempting to take 30 divided by 5 because that works out nicer, but 5 over 30 is how I have to set it up, because the 5 is the vertical change and the 30 is the horizontal. It's the rise over the run is another way of thinking of slope. The only work we have to do now is we have to reduce this fraction. Both of them are divisible by 5, so it'd be 1/6. And so 1/6 is my slope there. That would be the slope of the line. So that means if I graphed any of this info, I would need a little more info to graph that. But if I were to graph it from one point to another, I can go up 1/6, up 1/6. So up 1/6. It's going to be angled like that. So this right here would be the steepness of that line. I just don't know where it is because I don't know any of the individual numbers here. I just know how things are changing. So up 1/6, that is the measure of the steepness of that line. So the slope on that one is 1/6. And that's lesson 9.3.